more compositions now, and this one has 3 functions, not 2, so it's even more fun than usual. Take a look at that. That is just your normal g of h. Okay, we'll work through that, but the very next line is f of g of h. So we're going to take the results of the first one, plug that into the f equation. So let me work through that. It might be easier to see than describe. If I say g of h, right, we're going to do this one in red right here. G of h of x means, and you should always translate them this way, g of h of x. So we're going to take our g equation, which is something squared minus 2 times something plus 9. That's the equation for g, and you're going to plug h into that. Okay, so we get x minus 4, this is h, x minus 4 in place of all the x's. And now, simplify it, right? We want combined like terms, eliminate parentheses, all that. So what do we get here? I think I can do this in the space I have. It's going to be x squared minus 8x plus 16 minus 2x. Watch out for that negative sign. This is a plus 8 and then a plus 9. Okay, so our combined g of h looks like this. It's going to be x squared. Let's see, I'm counting on my x's here. It looks like minus 10x. And then plus 16, plus 8, plus 9, I think plus 33. Double check me on that one, but I think that's x squared minus 10x plus 33. Okay, so that is your answer to the first part. Now the second part, where it says f of g of h of x, should be thought of this way. This is f of g of h of x. Now we already calculated g of h of x, so you can plug that right in here. This is going to become f of x squared minus 10x plus 33, which means we're going to take that f equation, which is something goes here, that's your x value, plus 5. Okay, and the something is g of h, x squared minus 10x plus 33. Okay, now this one is very simple. There's hardly anything to do. It's just x squared minus 10x plus 38. That's because I didn't have any squareds or foiling to work out. Okay. Now, this question that you're looking at, if you're in your homework problem, may actually go on further than this. It may give you some other combinations. And there's something very important about compositions, which I want to point out right now. Generally, f of g is not equal to g of f, usually. Okay, sometimes it is, but usually it's not. So you can't ever assume that you can just switch the places of these things and have it turn out the same. Sometimes it does, but usually it's not. Now, the next question is, does it matter what order you do some of these things? So I'm going to leave this as a question mark to you, and you should be able to solve that on your own using this problem. If I do g of h first, and then compose that into f, versus composing f and g first, and then composing h into the result, does it matter? Okay, so there's your question to work on, but we're going to use these techniques to prove it.